Snowpark ML or Snowpark machine learning is a separate Python library with different APIs, application programming interfaces, and there are at least three such different areas. You have the modeling API, you have the operations API with MLOps, ML operations, and you have a data access API implementing a file system with a file set and framework connectors for PyTorch and TensorFlow. Let's have a look at all these different areas and just mention, the major contributions that Snowpark ML comes up with. Uh, at the modeling level, Snowflake created wrappers around these three major open source data science libraries: scikit-learn, XGBoost, and LightGBM. As you can see, the last two ones are for gradient boosting. Yeah, so that's a major technique used all over the place in Snowflake. Uh, they provided distributed SQL preprocessing for transformers. Transformers are scikit-learn classes like one-hot encoder, like label encoder, like normalizers or scalars, providing both these methods fit and transform because they may change data. And a major contribution here is the fact that the classes from Snowpark ML have the same names, but they are actually translated into SQL. They translate into SQL queries or SQL scripts executed on the SQL engine. Remember, scikit-learn is using actually pandas data frames to execute operations in memory. Well, with transformers in Snowpark ML, you can take advantage of the SQL engine, of the multi-node engines, and execute the distributed SQL. So Fit will automatically execute a store procedure for model training. This is important because if you have estimators like XGBoost, let's say regression classifiers, yeah, you have typical regression classifier classes. We've seen that in Snowpark, the traditional Snowpark, the previous iteration, you could create, and it was recommended to create a store proc and to execute all that code basically on the virtual warehouse, yeah, on the server side. Well, right now you have this store procedure automatically created by you. So they created upper wrappers basically that can do this. Also, at the main model training level for validation and for model evaluation, you have both distributed hyperparameter optimization, distributed APO, and they are using specific grid and randomized search CV classes. And they provide also distributed performance metrics. So distribution everywhere, taking advantage basically of the distributed nature of their SQL engine, including automatic store procs for model training. At the MLOps level, at the operation level, so they provide a model registry class. Definitely, any MLOps includes such a registry because you need to take care of model versioning, of saving the model and distributing it somewhere for prediction, for model serving. And yeah, prediction itself could be done just like before in temporary vectorized UDFs. They provided also data access, as I was saying before, and there are two levels here. You have one file system and one file set APIs or classes, and they provided framework connectors also for PyTorch and TensorFlow. This is a ML pipeline architecture that we had before with Snowpark. Yeah, the first iteration of Snowpark with no Cortex. Yeah, it's no Cortex yet, but you were able to execute, and they were pushing hard for us, for people to execute machine learning experiments. Yeah, but this way. So the major changes here, as you can see, are at the feature engineering, model training level. You had specific classes with specific fit and transform functions that you could deploy into a store procedure and execute in a Snowpark optimized, preferably a Snowpark optimized warehouse on the server side. But you had to write by yourself, such as the procedure, take care of details like providing a stage and so on. The model itself, yeah, was saved somewhere eventually in a named stage, and you could use a cache, yeah, with cache tools, just to serve it, in a better way. And looking at the model deployment or model serving side, it was recommended to use multi-node standard warehouses and to deploy all this into UDF, user-defined functions, to deploy the predict function here. It was even better to use vectorized Python UDFs, just in case you had to call this multiple times on a result set. What changed with Snowpark ML is the fact that, as you can see here, you have different kinds of processing in the feature engineering and model training right now. Because for the feature engineering, you have the data pre-processing classes like label encoding, as you can see here, one-hot encoding, normalizers, scalars, and so on. That right now they will translate into SQL statements, SQL scripts or whatever, but they are distributed directly into the SQL engine of Snowflake and executed there much faster. With multi-node standard warehouses, you can take advantage of the distributed nature of their SQL engine. For model training, the fit method is executed just like before into a Python store proc, except that all this happens internally. From the outside, the fit method looks like a regular, and it is a regular Python method. But inside, it will automatically deploy right now a store proc and execute inside that store proc. Just like before, is recommended to use. It depends. It depends on your data set, but you can use a Snowpark optimized warehouse. At the MLOps level, you can see here the model. For the model, yeah, they provided a repository, so-called model registry. So you can call log model and basically register a model, save a model, and register it here. The model itself right now became an SQL object that you can use directly, or you can call predict, yeah, on this model. For predict, just like before, you can use vectorized Python UDFs on multi-standard, multi-node standard warehouses. Let's see about some particular changes here in Snowpark ML related to the classes that they implemented from scikit-learn and the other two libraries. They try to keep the same name. They try to keep wrappers around some of them, but there are some differences, and you'll see. Constructors for estimators and transformers, you have five additional optional, usually parameters. So right now you have to pass in the constructor input-output column names. Yeah, if you remember in scikit-learn, you used to pass the column names basically into different data frames in the fit transform stage, but right now you pass them here. Fit predict will now execute with Snowpark or Pandas data frame. Yeah. Not inputs, weights, labels, arrays. Yeah. Transform predict we return a data frame with all columns from input data frame, not arrays. Yeah. So we used to use NumPy arrays, but they try to focus definitely on Snowpark data frames right now. Fit underscore transform is not used. Yeah, use rather fit follow by transform using a dot notation. And also, inverse underscore transform was judged as unnecessary.